Good morning. Today I'll be presenting my physics lab number 4 about oscillations. The purpose of this lab is to exemplify the physics principles of Newton's second law and the energy principle with an object swinging in an arc while oscillating on a spring. So Newton's second law is F equals ma, and the energy principle is when there are no surroundings, the change in energy is always zero, and when there are surroundings, the work exerted by external surroundings is equal to a change in kinetic energy plus the change in potential energy. So the principles in action. Newton's second law. This describes how the sum of the forces cause a change in velocity and therefore in position of an object. The energy principle. The change in energy of the system is zero if there is no external force. The potential energies can be converted into kinetic energy. So this is the experiment. The object selected to analyze was the mass. The center of the mass was tracked with tracker for each frame. The data of position versus time were recorded by the app. The origin was set to the fixed end of the spring. The x and y position data were exported into Glow script. Here's video of tracker tracking each position for the video of the mass oscillating on a spring. So the system and the surroundings. The system was the mass, the spring, and earth, and there were no surroundings. So the change in energy was zero, and energy was kinetic energy plus potential gravitational energy plus potential spring energy. And the same held true for changes in energy. Description of the computational model. The mass was of mass 0.402 kilograms. The relaxed length of the spring was 0.123 meters. The initial position of the mass was at negative 0.1167, negative 0.64, and 0. The spring constant K was determined to be 6.83 newtons per meter. This is how I got K. Now this is the video of the computational model. Here's the code to analyze the motion of the video and build computational models around the position data for each time. So here I import the CSV file, and as you can see, I build graphs for all the energies and the positions. Comparison. Both graphs have the same amplitudes. Both have roughly the same period. The y position is more closely together, and the difference is that the x position seems to differ by a slightly increased period. Possible sources of error. The period of the actual experiment may be different than the one calculated because the time steps by tracker may be too great, and it also doesn't give the exact point where it reaches the amplitude. What does it mean? Is the energy principle satisfied? Yes, the energy principle is satisfied, as there are no external forces doing work on the system, making the total energy remain constant and the change in kinetic energy be caused by changes in potential energies. What if we change the period of calculation from the y to the x position data? The x period was 1.615 seconds and the y period was 1.519 seconds. So K determined by the x period was 6.08 newtons per meter, and for the y period was 6.83 newtons per meter. As you can see, it is near accurate when determined by the x period. Here's the link to my simulation. Thank you.